Yeah, we short of fruit tables. Everybody saw. I think everybody wrote. All right, so proposition. So basically if you did physics and did logic gates, you didn't do this already. Okay, but instead of ones and zeros, you have to use the true and false. All right, very, very similar to what you did in physics. So a proposition is a statement that makes a declaration that is true or false and what's not true. A simple statement is a statement that cannot be decomposed into separate statements, compounds, where you put them together. Okay? Right? Ignore that algebra for now. Right. So here you want to go, we want to go into a couple of these, right? So the first thing we're looking at is what does T represent? T represents true, and it can also be represented by 1. As I said, we focus in really on using T. Okay, F is false, or it could also be 0. First thing you want to learn is what is negation, conjunction, disjunction. Here we have a worded version, right? I will give you the truth tables for all of this, right? Right, make sure your name on that list, right, all you. Right. So I want to start here. We want to start initially with the truth values. But before we do the truth values, I need to understand something, right? So if we have one variable, right? That one variable could only be true or false. That's okay? If we have two variables, P and Q, then one of them could be true. The next could be true as well. This one could be true. This one could be, here could be false, here could be false, and here could be. So if we have two variables, these are the options that we have. We have 4 options, right? So basically it looks like this. If it's 2 to the 1, so the general formula is 2 to the n. N is the number of variables. So what would happen if I have 3 variables? Very good. I'll have 8, right? But of course, you don't want to have to work out each one of them, right? Must have an easy way to write it out. So the easy way to list it out is 4 truths, 4 false. Right? 2 truths, 2 false. 1 true, 1 false. As the pattern you'll follow, right? And then here's 1. That okay with that? Right? So you have to pay attention to how many variables the question has. If it's 1 variable, just 2 options. If it's 2 variables, 4, here, 3. That's okay? So the first thing you want to learn about is negation. Symbol looks like that. If I give you P and I ask for what is the negation of P, what you'll tell me is the negation means the opposite. Right? So true will be, false will be true. That's okay? Right? What's the word that represents the negation? Not. Very good. Right? It could be represented by the word not. Right? Then we have conjunction. You all may have done this already. What the symbols look like? Conjunction. And what's the word? Well, I cannot spell it out. And. So you have PQ, right? This is a connector. So it will have 2 variables, P and Q. True, true, false, false, true, false, true, false. Right? If you remember the AND gate is only true when what? When both of them are true. Here will be true, false, false, false. That's okay? So that's conjunction, that's negation. And disjunction. Spell that right? Huh? Spell that right. That's speaking it wrong. Right? Or, so that'll be P, Q, P, or Q. So this is true, true, false, false, true, false, true, false. P or Q, once you have a true, they are all true. Yeah? In conjunction, no. Conjunction is only true. What you're probably talking about is biconditional. Right? I'll give you that test now. No, biconditional is if and only if something happens. So if one falls, and the next falls, and then the same. Come on, right? You're okay with that? Before I add on the next two, right? I want to talk about some of the rules of algebra, right? Copy them in the meantime now. If you do it already, you have it on your time. What? Finish? Ready? Right? So what you're going to see in And this same logic and reason, you're going to see something called algebra propositions, right? And I want to show you that you don't really have to memorize them. I want to show you how you can figure it out. Okay? So you might see something like this. P. So the first one you might see is P. And let's say P and true. Right? You need to figure out what P and true is. Right? So you remember how you have identities and trigs? Right. This is like an identity. P and true will always be something. We had to figure out what that something is, right? So let's pretend P is, so I'm looking at this truth table here. Let's pretend P is true. True and true is what? True and true is true. That's okay? But suppose P, remember, P can be true or P can be false. Remember that? P can be true or false, right? So if P is false now, what will this be? What will this be? False. So what is controlling the answer? P and? You're seeing that? So what controls the answer? P. So it means that P and true is P. That makes sense? Are you okay with that? Let's try the next one. Let's try the next one. Right? I'll leave that here for you to understand why, right? Let's try the next one. What is P and false? Think about it. What's P and false? Run through the two examples in your mind and see what the answer is. What do you think is the answer here? False. Right? Because when P is true, it's still false. When P is false, it's still false. What does that mean? It means that the false controls the whole thing, right? So P and false is false. So you don't have to memorize this. If you see it, you know how to work it out. You all okay with that? I'll leave this here for now, right? Let's try. I want you to try P or true, and then try P or false. 1, 2, 3, 4, right? Going this way, right? Try that for now. Online, you can message, right? What you think number 3 is, what you think number 4 is. Right, so you have to remember your truth table, right? So you're using this here. Ready? So what we have here, what do you think is P or true? True, right? Because once you have a true, you get true. That's okay? P or true is true. What about here? P or false is what? P is dependent on the value here. Everybody okay with that? Yeah? Right? While we're here, can you tell me what is P of P? And what is P and P? What do you think is P of P? What do you think is P and P? Think of the answer. But listen names one. I'll pick up some. To pick on one over. Narayan. As mouth Narayan. Yeah, mouth here. What is P of P? P, yeah. Right? Because if P is true, true and true or true is true. Right? And false or false is false. So it means that P or P is. What about number 6? Isa, what is it? Number 6. P and P. What about if both of them false? So it's dependent on. You okay with that? Yeah. Right? While I have you here, I can give you 2 more rules. What is the double negation of something? If we double negate something, we'll get back the original thing, right? All right, nice. Have some more rules, but I can't show you as yet. Hello? Last two. Last two. What is P and the negation P? And false. Because once they opposite, they get in false. That's okay? Yes, sir. What's the last one? What's the last one? True. Right? Once they are opposites, it will be true. Yeah? You okay with us? No? Yeah? Right, next. Next subheading, logically equivalent. Right, sorry. So what is logically equivalent now? To show something logically equivalent, we have to check and see if all the truth values are the same. Okay? So make a note of that, right? Right? Logically equivalent implies that the truth values, logically equivalent implies that the truth values that they are. What's down there? Logically equivalent implies that the truth values are. Huh? Oye, llena de un más. Vamos saying that. Right? Logically equivalent implies that the truth values are all the same. Right? For each statement. For each statement.
Excuse, I'm Vinay. Please come to the office.
Right. Let's see if we can prove that this is logically equivalent. All right. So you need to learn how to set this up. All right. How many variables we have here? P and Q alone, right? So two variables, P and Q. Then you have negation of P. Then you have negation of Q. What else you have? Right? So you're looking for all the compound state, everything in there. So you're seeing negation of P, negation of Q. What are you seeing here? P or Q. Then you're seeing that we negate that. What else we have? These two combined, right? Everybody okay with that? So those are the 1, 2, 3, 4, 5, 6, 7 things that we need. We have two variables, P and Q. We negate them. Then we apply disjunction. Then we negate that. And then we apply disjunction with, wait, I have this thing upside down. It should be and. Everybody okay with that? Joseph? You see how to break it up, right? And we have how many variables? We have two variables, so it's true, true, false, false, true, false, true, false. That's okay? And let's do this one together now. Negation of P is what? So looking at this, false, false, true, true. Negation of Q is what? False, true, false, true. That's okay? P and Q. So I'm looking at these two and I'm using your conjunction. True and true is false, false, false. Anybody lost? Everybody okay? Now we're going to negate this. So I'm negating this, so that'll be false, true, true, true. Right? I'm negating this. Yes, the opposite. Now I'm going to use P or Q. So I use an or here, that's false. This is true, true, true. Are they logically equivalent? Right? Everything here and here is the same. So 1 is equivalent to 2. Therefore, logically, right? Therefore, logically equivalent. Known as De Morgan. Copy it down. When you finish, you can try this. When you finish, you can try that next one there. Awesome. Next. You're done? Right, let's check it out. So I can take up this, I can take up this, and right. Right, so we need P or Q. Right, we need to negate that. And then we need to negate P and the negation of P. Right, so me figure this. This is true, 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 false. This is negated. This is negating this. Yeah. And then these two we ANDing, right? So false, 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 true. Are they logically equivalent? Yes. Right? Yeah. So the way to memorize this rule is this, right? It's like kind of multiplying. If you multiply a negation by P, you'll get this, right? If you negate this junction, you will get conjunction, and if you negate Q, you'll get it. Right? Not totally accurate, but it's a way for you to remember the rule. Okay? By expanding this out, you should get it. That's okay? Nice. Let's take a look at converse truth table and biconditional. All right? All right, so what's here? Right? So we need to understand, right? We need to understand conditional and biconditional. Conditional, the worded version for this symbol here implies. P implies Q. Right? If you see the double arrow, it means biconditional, it means if and only if. Right? So conditional, right? The only time conditional is false is when a true statement implies false. Every other time, the true. True, false, true, true. Biconditional, whenever both of them are the same, it's true. True and true, true. False and false, false. Other than that, false. This one? Yeah. So conditional, the truth table for conditional is this. So a statement is only considered false if we have true implies false. True implies false is always going to be a false statement. A false statement could imply true, and a false statement could imply false. Right? But the only one that cannot is this one here. So when you have to learn and memorize, you memorize this one alone.
Say the explaining logic behind it.
Which one?
Why a four if it P is false and C.
Okay, yeah, I will show you a nice worded example
Yeah.
that will explain it in a little while. Right, but not every example is be so clear, right, Dante?
Yeah.
We want to show you to work for, but it doesn't work for every single one. So for now, just accept it like this for now. And I'll show you. Right? So I gave you two of them on one truth table, right? Double. Ready? Are you ready? Right, so we have three more definitions or three more terms to understand. If I give you P implied Q, right, you need to understand what's the converse of that, what's the inverse of that, and what's the contrapositive of this statement here, right? Real simple. Converse is just pushing these two around. Okay? So if I said what's the converse of P implied Q, converse is Q implies P. Inverse of this statement, inverse of it is just negating the P and the Q right where they are. That's okay? And last one, contrapositive is when you converse the inverse. What does that mean? Push them around, right? So it will be the negation of Q implies the negation of P.
Can she go on Monday?
Time to 3 as well. Right, so as I said, contrapositive is what again? What's the next way to explain Narayan? What's the next way to explain contrapositive? Converse of the inverse. Converse of the inverse, right? For those who are not seeing online, converse of the inverse. Converse of the inverse. Well, you okay with that? Everybody okay with us? So then the first set of rules that we need to know, right? Let us see if we can put this together now. Around 5 to 2, we'll do that. Right, before we start this one, let's take these two definitions. Tautology. Look at that, tautology. T-A-U-T-ology. Right, a tautology. Right there, T-A-U-T-O-L-O-Y. A tautology occurs when all of the truth values are true. A tautology occurs when all of the truth values are true. Every single one of the values, true, true, true. So it's like here, all of our values, all of our truth values will be true. That's okay? If that happens, what we have is something called a tautology. And next definition, a contradiction. Next definition, a contradiction. A contradiction occurs when all of the truth values are false. Try that, please. Complete that truth table. That's 2015. Yeah, 2015. 2015. Try 2015 number 1A. The remainder here, 2015. Take your time and see if it's a tautology or not, right? There are tautology. Okay? Ready? So negation of P, that will be false, false, true, true. Negation of Q, that will be what? False, true, false, true. P or Q, true, 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 false. Right? Double negate them, and conjunction, that would be false, 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 true. That's okay? And now we are going to disjunction there. True, 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 true. So therefore, to polish. You okay with that? Okay. Right, before I move on to the next one, right? Sometimes you don't really have to understand it. You could just accept it. That true implies false will give you something false, right? But there's a kind of way to conceptualize it, right? So here's what this statement is here. This statement P or show. Right. This statement P here are basically the promise you're making. Right? So if you make a promise, right, and it's true, you expect to get that promise, right? So you expect it to be true. That makes sense? But if somebody don't make a promise to you, it matters? Don't matter. If it's true or false, it doesn't matter. So if you think of it that way, what you're saying, if your father make a promise to you and it comes true, that's good. Right? If your father don't make a promise to you, but it comes true, you're okay with that? Your father don't make a promise to you and it don't come true, you're okay with that? But if the man come and make a promise to you and it don't come true, you'll be mad. Right? You okay? So you can kind of conceptualize it like that. Are you okay with that? Right? But then again, they might not ask something to explain it, but I just want you to kind of always remember this. Right? You make a promise, you have to keep it. Don't make a promise, it don't matter. All right? And I'll see the example. That's the number. Let's explain it to you like that. Everybody okay with that? Right? So let's try some more, right? Let's try some more. Oh wait, that's right.
I don't invite. Yeah.
Prove this, please. Prove this, please. For now, you only know one technique, and then I'll show you our next technique after. Use truth tables and prove that. 16. Put someone 15. No, that's- Try that, please. Still, I'm not in the group yet. We sort out tomorrow. Right? Make sure and give. Yeah. Go ahead, yeah. Go ahead. Yeah, you're right. That's not problem. Wait, hello. Yeah, somebody do it, right? So you get a part, you can do it. Well, no, it's right, Dr. Burrow. That's not. Yeah, yeah, you got Dr. Burrow. All right, let's see what happened here now. Was it true?
Yeah.
Yeah. That's true, true, false, false. True, false, true, false. Negation of B, false, false, true, true. Or will be true, 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 false. Right? P or Q and the negation of P. That will be I got false, false, true, false. And then negation of P and Q, I got false, false, true, false. What does that mean? Identical, so they're logically equivalent. Right. Notice this question did not tell you to use truth tables. So it means that there must be a next way as well. Right? So I'm going to show you the next way. Right? So write this example down and underneath write algebra propositions. Okay? To be honest, the algebra proposition never came before, but it's on your syllabus. So that's a lot of showing. Right, but I'll do this on the board and I'll write down all the rules I'm going to use. Right, I'm going to use that and then I will use that. I should have that. Right. While I was doing it like this. All right, ready? So Narayan, here's the problem, boy, Narayan, boy. Narayan, we had to take this right hand, left hand side and make it equal to the right hand side. So what I'm going to do here for you is write down the rules I'm going to use, or the laws I'm going to use. The first law I didn't give it to you as yet, right? It's like expansion law. It's called the distributive law. Right? So I want you in your mind just to envision multiplying something out. Right? So if I give you 2 multiplied by 2 plus 3, sorry, 4 plus 3, what you'll do? 2 by 4 plus 2 by 3. And you'll normally do that. So we're going to do the same, we're going to do the same thing here. Right? We're going to multiply P and Q. So P and by Q, P and by R, and then O in the middle. That's okay? That's called the distributive law. Okay? P and by Q, P and by R, and then O in the middle. Everybody okay with that? No? So You understand the multiplication example I gave you here? 2 by 4, right? So 2 by 4 plus 2 by 3. In the middle, because that's the symbol in the middle. 2 by 4 plus 2 by 3. 2 by 4, 2 by 3. Right? And after we use that, we might go back and use this rule here. What was that again? What was the negation of P and P? I gave it at the beginning of the class. And false, and false. Right? It's an AND gate, right? And if the two inputs are opposite, and it's always false, right? And then one more law. What is false or anything? Or what is false or anything? True. Sorry, not true. P. Everybody clear with that? Right? False or P is always dependent on P. You okay with that? Yeah? Right. So I'll give you the rules. Of course, you have to learn it. And I'm going to show you how to use it here. This never came before, but it's something that's on your syllabus, so should have an idea. It actually came already in paper 3, but you all don't do that. It came twice in paper 3. Right. So I want to use those laws here. So the first thing I will do, I don't like when it pairs, so I just go and switch it around. Right? That's like a basic commutative law, right? It looks easier like this, huh? As opposed to this. Now I'm going to apply rule number 1, the distributive law. Negation of P and P. Negation of P and Q. And what goes in the middle? Can't jump. Just jump. You okay with that? What is the negation of P and P? Right? It's only one brackets, right? What is false or anything? Anything, right? What is false or P? We said it was P. So this whole thing here is like a P. So you'll end up with the negation of P and Q. Therefore, you can write your little QED there. Left hand side equal to right hand side. Okay with that? Right? Never case, I'm not going to give you too much examples on it, but I just want you to understand how to get. Okay? I want to give you one just to try. Huh? Let me know. I use distributive law here to expand it out. And then I use negation of P and P, this law here, to get it false. And then I use false or anything to get this. That's okay? I guess, right. Right, so I'll give you one from here. My brothers was the thing. So this one is very similar to what we just did, right? Right, try that there and we will stop there for the. Okay, now, I'll get too excited. Next one. Okay, next.
Claro.
Right? No truth tables, algebra alone. No truth tables. Anybody get? Yeah? Yeah? Oh, we can do all of it. Anybody come and do it? Anybody will come and try it? Alright, so you've proven that quick. Which law he used first? Distributed, right? False. Right. Right, yeah, that can work. And what? Again? All right, nice. So that gives us an idea, logic and reasoning. We will do a few next week, probably a Kahoot as well, and then jump into axioms. You know something about axioms, like things you know already, like commutative law, distributive law, and use it to prove things. Right. So watch here. So the first thing you did is switch it around. Right? You switch it around. Right? And then you expand this out. So P, Q or P, Q or negation of Q, and in the middle. Right? What is Q or negation of Q? Right, Olia, this is supposed to be true, right? Q or negation of Q is true. True and anything is anything. You make a mistake here. Huh? I wanna fix it. I wanna I'll just edit the right? You okay with that? Supposed to be true here, right, Olia? Alright. It was supposed to be true. Alright, nice, Olia. So pure maths, that's it.